Okay, so my voice is audible to all.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, it's very nice to see you after a long time.
तर काय झालं?
कोविड दुसरं काय होणार आहे बाबा?
Are you feeling well now?
No, still I'm in my quarantine period only now. 7 to 8 days are there, but your academic loss will be there. That is why I'm conducting from home. The one more problem that you have to adjust it. I won't be able to start my video because when I try to start my video now, I'm not getting the bandwidth and it is getting disconnected. So I hope now my voice is clear to you.
Yes, sir. It is clear.
Okay, now I will share the screen because what is happening now, I'm connecting from my mobile. So when I share the screen for our whiteboard and simultaneously if I try to on the video now, it is not working because of the low internet speed. So so now what we will do for today's lecture now for 2-3 lectures. I'm requesting to all of you to please adjust that. After this 3-4 days now, when I will be back in the college, then we will take our lectures like regularly, whatever I'm taking by switching on my video. Okay, so is it fine?
Yes, sir. No problem.
Okay, so in the last lecture now, we have gone through the Lamest theorem. So I quickly tell you what is the Lamest theorem, and then we will discuss how to solve the numericals by using the Lamest theorem that we will discuss. Okay, so the screen is visible to all of you, the board.
Yes, sir.
Okay. So now the Lamest theorem, what it states that if the three forces are there which are meeting at a single point, now I will draw the diagram. Suppose now this is a point. So from this point now, if three forces are acting, F1, F2 and F3 are these three forces. Okay, only three forces are there, then and then only you can use the Lamest theorem. Please keep in this mind. Only three forces are there, then and then only you can use the Lamest theorem. That is the first thing. Second thing is that those three forces should be coplanar concurrent forces. That is the second thing. And the third thing is that whenever you are using the Lamest theorem, either those three forces are moving in outward direction. So either those three forces are tensile or all these three forces should be compressive. Okay, so either pull is there or either push is there. It should not be the case that two forces are showing in pull direction, that is tensile direction, and one is push, that is the compressive. So in that case, you have to use the law of transmissibility of force and you have to shift accordingly the direction of the forces along its line of action. So how to do that I will tell you when we will solve the numericals. Just now for your brush up now, I will tell you, suppose this force is F1, this force is F2, and this force is F3. Okay, suppose now these three forces are there. Suppose this angle is alpha, this angle is beta, between F1 and F3 it is beta, and suppose now this angle is gamma. So these three are the angles. Then what the Lamest theorem says that? Lamest theorem says that F1 upon sine alpha, that is the angle between other two forces. When you are taking F1 at the numerator, 1 you have taken at the numerator, then you should consider the angle between other two forces, 2 and 3. Okay, so F1 upon sine alpha must be equal to F2 F2 upon sine beta, which is equal to F3 upon this is F3 is here. So the angle between F2 and F1 is gamma. So it is F3 upon sine gamma. This is our Lamest theorem. By using this theorem now, we are going to solve the numerical. Okay, so what are the points I have told you? You should remember those points, and those are the limitations of Lamest theorem. What is the limitation? First is you cannot apply this theorem when two forces are there or four forces are there. Only and only for three forces you can apply the Lamest theorem. If the fourth force is getting involved in this, then you cannot solve by using the Lamest theorem. You have to use summation fx and summation fy to solve the problem if the more than three forces are there. That is the first thing. Second thing is that all the three forces must be coplanar concurrent forces. They should act at a same point. It should not be the case that the two forces are acting on a single point and third force is acting on another point. Then you cannot use Lamest theorem. Remember these points. Third point is, I have already told you, all forces should be inward or all forces must act outward. Now in this case, you can see all forces are acting outward. That is tension. This is pull. Okay. So this should be the case for the these are some scenarios in which you can use the Lamest theorem. Okay, so I will tell you some free body diagram. So before going to the free body diagrams, in the 9th, 10th standard, you have learned one theorem in the geometry. That one theorem is that the angle between the lines is angle between their normals. This theorem we required over here to find out the angles. Okay, this is the very important theorem which is required. So I will rebrush to you that theorem also, so that it will be easier for you to find out the angles while we solve the numericals by using the Lamest theorem. Okay, so I will write that theorem and I will explain it to you. You might have forgotten that because it is long time now. So I will write the theorem first. So theorem is that angle between the lines is the angle between their normals, or is equal to the angle between their normals. Angle between their normals or tangents. Their normals or tangents. Okay, now you know the word normal and tangent. So what does it basically says that if two lines are there, okay, and the angle between the two lines is theta, if you draw two another lines such a way that whatever lines you have drawn, those two lines are parallel to the perpendicular to the earlier lines, then whatever the angle between those two earlier lines, the same angle must be there between the two new drawn lines. So now I will draw the lines. I will tell you how it works. So now suppose this is my first line, okay, and then this is the second line, okay. So the angle between these two, if I say that the angle between these two is theta, okay, these are the two lines I have drawn randomly. Okay, one line is horizontal, another line is inclined. Now I will draw two more lines. Suppose now this is the horizontal line, the line which I have drawn at bottom. Suppose I draw one line like this. Okay, now you can see that whatever line I have drawn, so this angle is 90 degree. This line angle is 90 degrees. So if I give the name, suppose now this is A, this is B, this is C, I will call this point as D and I will call this as E. So you can see here that line AB is perpendicular to line D and vice versa. You can say also that line D is perpendicular to AB. Okay, and now if I draw one more line, suppose now from point D, I will draw it like this. Okay, and I will call this point as F. Now again you can see this angle is 90 degree. So here I can say that AC is perpendicular to DF, or you can say that DF is perpendicular to AC. Okay, so in this case now you can clearly see over here this AB line. To this AB line, this D is perpendicular, and to this AC line, this DF is perpendicular line. So if the angle between AC and AB is theta, then the angle between D and DF, it must be also theta. This is the theorem which says that angle between the lines is angle between their normals. Is it clear? Yes, no?
Yes, sir.
आठवतंय का कधी काय केलेलं काय असं जरा आपण शिकलेलो आहे हे 9वीत किंवा 10वीत तुम्हाला झालं असेल हे की दिस इज द थेरम इट इज theoretically proved. Now I will not go to the proof of this theorem. You can refer your earlier books of when you were in school or in college. So this is the theorem you should remember. The angle between their lines is angle between their tangents or normals. Okay. So whenever two lines are there, and if you draw two more lines such that those two more newly drawn lines are perpendicular to the earlier lines, then whatever the angle subtended between the earlier lines, it must be equal to the angle subtended by the new lines. Okay, so if this angle is theta, here the key point is if this angle is theta, this angle is also theta, because for this AB, this line is perpendicular D, and for this AC line, this DF is perpendicular. So if angle between AC and AB is theta, then the angle between D and DF is also theta. So this is the important, I will mark star over here. You should remember this theorem. Okay, you must remember this theorem. This is very important theorem which we will require in applied mechanics every now and then. Then other things, I'm not going into the details. You know what are the corresponding angles, you know what are alternate angles, you know what is opposite angle. Okay, so I hope now you know all these things. So by keeping in this mind, we will move further for some free body diagrams. I will draw 2-3 free body diagrams in front of you so that you will get some idea how to draw the free body diagram. Okay. Now suppose a roller is there or a sphere is there which is rest on the surface. So now if I draw the surface, so this is the surface. Now on this surface, if I draw the sphere, okay, so this is the sphere. Okay. Now if I draw the free body diagram, let us say that this is having a weight W. What is the weight of this sphere? The weight of this sphere is W, and it is resting on this surface. It is currently rest on this surface. This is the horizontal surface on which it is kept. Okay. Now if I draw the free body diagram of this sphere, then how will be the free body diagram? So I will draw the sphere. There is no need to draw the sphere again. If you show the forces, then it is also okay. But to make you understand, I am drawing this. So what is the thing now? If you see this sphere, the centroid of this sphere may be somewhere here. This is the centroid of this sphere. So the weight is always acting vertically downward from the centroid. You can write this sentence. This is very important sentence. The weight is always acting through the centroid, and it is always act vertically downwards only. Whatever may be the position of the body may be kept on the horizontal plane, then also weight will be act vertically downward. If the body is kept on the inclined plane, which is inclined at an angle theta, then also the weight of the body will act vertically downwards only. There is only one direction for the weight, which will always act vertically downwards. Okay. Now if I show the weight of this body, I can show it by two ways. I can show the arrow, it is like this. Suppose now this is, I will use another color. See, this is the weight W. Okay, so this is the weight W that can act on the body. Okay, so instead of showing it like this, I can show this weight according to law of transmissibility of force. I can shift this on like this also. This is also one way of showing the weight. Okay, I can show it like this, or either I can show it like this also. This is also correct. Whatever I have shown over here, this is also correct. This is the direction of the weight, and now you can see I am shifting this along its line of action. I am not changing its line of action. See, I have shifted it like this. Okay, so this is also the one way to show the weight. So I will show it right now like this. So I will show it here W, whatever may be the its unit, Newton, kilonewton. This is the weight of the sphere. I am drawing now free body diagram. Okay, now next thing is that you can see this is the surface. And on this surface, this sphere is rest. So whatever weight of the sphere, it is acting vertically downward. Okay. So due to the weight of the sphere, you will get reaction from the floor. Okay. To maintain the equilibrium, otherwise what will happen? जेवढं काय ह्याचं जे वेट आहे, हे वेट जेवढं वर्टिकली डाऊनवर्ड ऍक्ट व्हायला लागले, तेवढीच या सरफेस मधून तुम्हाला अपवर्ड रिॲक्शन मिळते. म्हणून हा स्पियर जागेवरती आहे. जर तुम्हाला या सरफेस मधनं ही जर व्हर्टिकल रिॲक्शन मिळाली नाही, तर हा स्पियर इथून खाली मूव्ह होईल. ओके, इट विल ट्राय टू पेनिट्रेट थ्रू द फ्लोअर. आर यू गेटिंग माय पॉइंट? सो whatever the weight of that sphere, equal and opposite reaction you will get from this floor. Okay. Now, how do I show the reaction for whatever we are getting from the floor? So I will show that reaction. See, that reaction will be like this. This is the reaction, whatever we are getting from the floor. I will call this as reaction R. I will call this as reaction R. Now I will show these two same forces in the main diagram. Suppose now this is centroid. Okay, this is our horizontal line. This is vertical line. Okay, so weight, if I show over here, the weight will be like this. Okay, this is the weight. If I show the weight, this is the weight. In this way I am showing the weight, but according to law of transmissibility of force, I can shift it along its line of action. So I have shown the weight like this. Again, if I show the reaction, my reaction will be in this way. This is my reaction. Okay, so you can also shift the reaction to upward, but there is no need right now. So this is my reaction R, and here is my weight W. Okay, and the key point, one more thing, you should always remember that this reaction is always perpendicular to the surface, no matter how the surface is. If the surface is horizontal, the reaction will be vertical. If the surface is inclined, then the reaction is always perpendicular to the surface. This reaction R, whatever you are getting, it is perpendicular to the surface always. Also, you can note down this point also. This is also very important point. Whatever reaction you are getting from the surface, that reaction is always perpendicular to the surface. Okay, so whatever I have told you in this 5 minutes discussion, are you able to pick something from that? Have you understood this, whatever I have told you right now?
Yes, sir.
Okay,
Yes,
don't
sir.
think about Lamest theorem right now. Then how we are going to use Lamest theorem for this sphere, how we are going to solve it. Don't think about that right now. That I will tell you while we are solving the problem. Just now try to understand the concept. Okay, so I'm trying to tell you how we can show the weight and how we can show the reaction. That is the only thing whatever I want to tell you right now. Okay, so if you are understood this, then this is very good. So this is floor. This is called as floor. Okay, this is one type of diagram. Now, if we go for another diagram, I will draw another diagram. So this is number one. Now I will draw number second diagram. So here, what I will do, I will take some what complicated diagram. No, first I will draw the sphere. Suppose now this is the sphere. Okay, now this is the one line. It is like this surface, and the second surface for this sphere, it will be like this. And these are the two contact points. Here the sphere come in contact with this surface at point A. Here the sphere is come in contact with this surface at point B, and suppose this is point O. Okay, so these two are the floors. These are the surfaces. So I will show it like this. This is the normal. Normally we show the surface like this. Sometimes in the examination they won't give you the line like this, but you should understand that the surface is given. Floor is there. So now we want to draw the free body diagram of this sphere. Again, see the weight of sphere is W. Again, you can see the weight of sphere is W. Now, instead of going for the separate free body diagram, what I will do, I will draw the free body diagram in this diagram here only. Okay. So here now you can see this is the sphere. So the centroid of the sphere must be somewhere here. Here is somewhere the centroid of the sphere is there. Okay. So if I draw the weight right now, I can show the weight vertically downwards. So I can show the weight like this. Just a minute. I can show the weight like this. This is the weight W, which is acting vertically downwards. This is the weight of the sphere. But according to law of transmissibility of force, I can shift that weight along its line of action. So I can show it like this also. This is the weight of the sphere W. Okay. This is the weight of the sphere W. Now after this, here you can see there are two contact points. Here in the first case, there is only one reaction because only one contact point is there here. Okay, now there are two contact points, point A and point B. So you will get two reactions. Okay, you will get two reactions. From each floor, you will get the reaction. Now you can see first reaction we are getting from this point A. So if I draw that reaction, you can see this surface. Now you can see the surface A or the floor A. The surface A is vertical. If you see this surface is vertical. Okay, and I have already told you the reaction, whatever you are getting from the surface, that reaction is always perpendicular to the surface. Okay, that reaction is always perpendicular to the surface. Now see, this surface is vertical surface. Then how will be the reaction? If the surface is vertical, how will be the reaction?
Horizontal, that is perpendicular to the surface.
Correct. The reaction will be horizontal, that is the perpendicular to the surface. Now, if I draw the horizontal reaction, this reaction you can see it will be like this. So, this is the reaction. Okay, so this is the reaction. And now you should always remember this, the angle of the reaction, this angle with the surface is always 90 degree. Yeah? Whatever may be the nature of the surface, this angle is 90 degree. So I can call this as reaction R at point A. So I will call this as RA. So RA is horizontal. Why RA is horizontal? Because the surface is vertical. From where you are getting the reaction on this sphere, that surface is vertical. That is why your reaction is horizontal, because the angle between the reaction and the surface is always 90 degree. Please remember this. Next thing is that if you think about now this point B, now you can see that this surface B is inclined surface. Now here you can see this surface is the inclined surface. This is not horizontal surface or this is not a vertical surface. So the reaction, whatever you are getting from this point B on this sphere, that reaction will be perpendicular to this surface. So if I draw the reaction will be, I will draw, see, this will be the nature of the reaction. This is the reaction. Okay, and I will call this as, RB. And you can see that this angle with the surface is always 90 degree. Okay, this angle is always 90 degree. So I hope now you are clear with the free body diagram, how to draw the free body diagram of the sphere or any object, whatever the sphere. It is easy for the understanding, other is easy if the rope is given. You can always remember one more thing. Whenever two objects are tied with a string or a rope, जेव्हा कोणतेही दोन ऑब्जेक्ट हे एखाद्या दोरीने बांधलेले आहेत, यू आर युझिंग अ स्ट्रिंग. ओके, तर दोरी लावून आपण कुठलीही गोष्ट ओढू शकतो. आपण कुठलीच गोष्ट कधीच दोरी लावून ढकलू शकत नाही, ही गोष्ट लक्षात ठेवा. इफ यू टाईड अ रोप टू एनिथिंग, यू कॅन पुल दॅट रोप. You cannot push that rope. So you always remember that rope always carries tensile force. Rope is not able to carry the compressive force. ओके, दोरी लावून तुम्ही कुठलीही गोष्ट ओढू शकता. तुम्ही एखाद्या गोष्टीला दोरी बांधली, दोरीला ढकलायला लागलं तर ती गोष्ट जाईल का पुढे? कुठली, वॉट एव्हर मे बी द थिंग इज देअर, it will not move, because the string always carries tensile force. String is used to pull the objects, it is not used to push the object. But instead of string, if you use a bar, it may be aluminum bar, brass, steel, iron, whatever it may be, a steel solid bar. If you use the solid bar, it can connect the two objects, it can push the object as well as it can pull the object. Okay, so this is the basic difference that you should always remember. Whenever in the problem they tell you the string is there, a rope is there, then the first thing that should struck to your mind is that if the string is given, if the rope is given, then it will always carry a pull force. Pull must be there. You cannot apply push force to the string. Okay, so these are some of the things which you need to remember. I think now it is clear to you. Okay, So we will see the free body diagram again when we will come across the numericals. So now with this note, I will move forward to the first numerical. So anybody is having any doubt in this, whatever I have told you right now? Any doubt? Anybody is having any doubt in this? Yes, no? Okay.
No, sir.
Okay, so shall we move to the numerical then?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So I will write down the problem first. So see, find the magnitude, find the magnitude of force P, find the magnitude of force P required to keep to keep the 100 kg mass, the 100 kg mass in the position by string as shown in figure, So they want us to find out the magnitude of force P. So we have to find out what is the magnitude of force P required to keep the 100 kg mass in a position. Okay. So 100 kg mass is there, that should be remain in its position. Okay, and it should be remain in its position by string as shown in figure. So I will draw the diagram now. So here, this is the point where this mass is there. Here the mass is attached. This is of 100 kg. This is of 100 kg. Okay. So force P, it is given over here like this. This is the force P, which is perfectly horizontal force. So this is force P, and it is tied by a string. This is the given diagram of whatever I have drawn. I am drawing. So here the string will be there, and it is tied to the surface. In this way, the string is there. And this angle is given to you between the string and this force P. This angle is 120 degree. So all these things is the given thing. Now we need to solve this problem. So this is the given problem to us, and they told us to find out the magnitude of force P required. So the magnitude of force P, if I want to find out now, see, first thing you should see here, this is the string or this is the mass which is hanged here, which is having a 100 kg. So the force of 100 kg which is acting downward. Okay. So and it is attached to the string. This is the string. Okay, so due to this mass of 100 kg, there will be some generation of the force in this string also, and we have to find out the force P such that this 100 kg mass will remain in its position. It should not move here and there. Okay, so now if I try to draw the free body diagram of this, see how I'm going to draw. So first of all, I will draw this downward force. This is the downward force, which is of 100 kg. Okay, weight. Then here it is my force P. It will be like this. This is the force P. And I have already told you that string is always carries a pull force, a tensile force. String cannot apply the push force. It cannot push on any object. Okay, so string is always carries the pull force. So pull means arrow is outward, arrow is away from the point. So this is the pull, and I will call this as T. And this angle is given as 120 degree. Okay, this angle is obviously 90 degree, okay, because weight is always act vertically downward and this force is horizontal. And this remaining angle, what will be this remaining angle? If this is 120, this is 90. So you can do 360 minus 120 minus 90. What will be the remaining angle? What is the answer? See, the angle between this T and this force P, it is already given 120 degree. This force P is the horizontal force. Okay. So this angle is 90 degrees. So 120, 90. So this remaining angle, I'm not able to hear. Can you please repeat the answer? I'm not
150.
150. Okay. 150 degree. So this remaining angle is 150 degree. Now it is very simple. Now you can see here three forces are there. Okay. So if the three forces are there, then these three forces you can use the Lamest theorem. Then you have to check another thing, that these three forces are acting on a single point. Yes, all these three forces are acting on a single point. Then you have to check that whether these all three forces are outward or whether these all three forces are inward. So here you can see that all the three forces are moving in outward direction from this center point. Okay, all these three forces are moving in outward direction. So we can use the Lamest theorem over here. One more thing you need to identify over here, that they have given you mass. So they told you the mass M is given 100 kg, weight is not given. So if I want to calculate the weight, you know the formula, W is equal to M into G, mass into acceleration due to gravity. So W is equal to, it is mass is 100 kg into, this is 9.81, acceleration 9.81 Newton per mm square. So if I calculate the weight, okay, if I calculate the weight, then it will be
981 kg.
981 Newton. 1
Newton.
kg is near about 9.81 Newton. Remember this. 1 kg is equal to 9.81 Newton. So for 100 kg, you need to multiply it by 9.81. So it is 981 Newton. So here, instead of the writing this 100 kg, I will now write the weight in its proper unit, and it will be 981 Newton. Now we have to solve this numerical. Okay, so now we can use the Lamest theorem. So here I will write the Lamest theorem below this only. So if I take the first force as T, so T is the tension divided by sine of. Now I should take the angle between other two forces. See, this is my T force. So this is T force. I should keep this T aside now. If I take the T at the numerator, I should not think about the T. Then who the remaining forces are? This is P and this 981 Newton. These two are remaining. So what is the angle between these two? It is 90 degrees. So that angle I should take at the numerator. So this angle is 90 degree, which is equal to. Now next force is this P. So I will write over here P at the numerator divided by. You tell me what will be the angle I should take? Sine of
150.
150. Okay. When I am talking about this P, I have taken this P at the numerator. I should left the P and I should think about the other two forces. So other two forces are this T and 981. So what is the angle between these two? The angle between these two forces is 150 degrees. So I will write here 150. Which is again equal to, what is the third force? It is 981. So 981 at the numerator divided by, what is the angle? Sine of 120 degree. Okay. Now you can equate the terms and you can find out the value of T and P. First equate first term and third term, you will get the value of tension in the string. Then you can equate the second term and third term, you will get the value of force P. Okay. So if I equate these, then I will write here P divided by sine of 150, which is equal to 981 divided by sine of 120. Now, if you solve this, you will get the value of P. Therefore, P is equal to, it is 981 divided by sine of 120 degree into sine of 150. Let me know the value of force P after solving this. What is the answer?
566.38 Newton.
Okay, so it is 566.38 Newton. Just wait. Okay, so 566.38 Newton. So this is the value of P. Similarly, you can equate T and this. So if I equate T divided by sine of 90 degree, which is equal to, again, I can equate it to 981 divided by sine of 120 degree. So therefore, T is equal to, it is again 981 divided by sine of 120 degree into sine of 90 degree. So if you solve this, you will get the answer of T.
1132.76.
Okay, 1132.76 Newton. So this is the value of T. So now we have solved for P also and for T also. So this is the pull in the string. So this string will have this force. या string मध्ये किती force असणार आहे tensile force 1132.76 आणि हा force P जो आहे तो किती force तुम्हाला अप्लाय करावा लागेल की जेणेकरून हे मास त्याच्या पोझिशनला राहील तर तो फोर्स तुम्हाला अप्लाय करावा लागणार आहे 566.38 न्यूटन. दिस इज द मीनिंग ऑफ दिस प्रॉब्लेम. So now this is the problem in front of you. Anybody is having any difficulty, you can ask me right now. This is the basic problem which I have taken to by which you can understand the concept of this, how we are going to use the Lamest theorem. So anybody is having any difficulty, you can ask me right now. Or if you don't have any difficulty, no? Shall we move further? Everybody understood this numerical? Yes. Okay.
Yes. Yes, sir.
तुम्हाला समजले तर पुढचा प्रॉब्लेम घ्यायचा काय याच्यामध्ये अडचण नाही.
No, sir.
Okay, so now if you understood it, then it is very good. So आता बघा इनडायरेक्टली आपण इथं काय केलंय. सो हिअर ऑल्सो आय विल टेल यू दिस इज द व्हॉट वी कॅन से दिस इज नॉर्मली गिव्हन एज दिस इज द स्ट्रिंग अँड इट इज अटॅच टू समवेअर. इट मे बी काय म्हणतात एखादा खिळा मारून त्याला अडकवलेला असेल किंवा एखाद्या रूफ मध्ये अडकवलेला असेल हँग केलेला असेल. इट मे बी द स्ट्रिंग. सो हिअर इनडायरेक्टली वी हॅव ड्रॉन दिस फ्री बॉडी डायग्राम. यू कॅन सी हाऊ वी हॅव शोन द फोर्स इन दिस स्ट्रिंग. सो दिस इज नथिंग बट फ्री बॉडी डायग्राम. Here you can see the 100 kg weight is given, it is like this. So we have directly shown the force over here. This is 981, this is because of this conversion. Okay, but this is called as free body diagram. Whatever you draw the diagram in which all the forces are there, you show all the forces, all the angles which are there in the given diagram. So that diagram is nothing but the free body diagram. Okay, so now we will move further for the next numerical. So the next is a sphere. A sphere hangs by a cord Cord is also word used for the string or rope. Huh? Don't get confused with this word cord. And rests on a smooth vertical wall. On a smooth vertical wall. Okay. Determine the tension in the cord. Determine the tension in the cord and the reaction exerted by the wall against a ruler. The wall against, here instead of spear they use the word ruler. Okay, the spear लाच म्हटलेलं आहे त्यांनी roller. Okay, full stop. Some given data is also there. So take mass of spear is equal to 100 kg. Then diameter of spear which is equal to, diameter is 200 mm, and then length of cord AC, is equal to 100 mm. This is the given data, and diagram is also given to you. So I will draw the diagram. So first of all, you will draw the spear. So this is the spear. Then surface is there, vertical. It is like this. And now I will draw the cord. Here somewhere the centroid is there. So you should always consider all the forces from the centroid. So now this cord, it is like this. Okay. And this is the surface. So this is only the given diagram. They call this as, this is point A, this is C, and they call this point as B, where it come into contact with the surface, this sphere. That is the point B. So this is the only given diagram. Now what you need to calculate here, determine the tension in the cord and the reaction exerted by the wall against the roller. So you need to calculate what is the tension in this cord AC and what is the reaction RB, that you need to calculate over here. So here if I draw the free body diagram first, see carefully, if I draw the free body diagram, so I will, first of all I will draw the sphere, then I will draw the surface so that it is easier for you to understand. Now if I draw whole diagram instead of directly drawing the forces, now I will here centroid is there, somewhere here the centroid. So if I show first the reaction, see the surface is vertical. Now my surface is vertical. If you see, this is the vertical surface, so my reaction must be horizontal. So that horizontal reaction I can draw. This is the horizontal reaction, and I will call this as reaction RB. Then second thing is that weight. So weight of this pair must act like this. You can show it by using the law of transmissibility of force also, or by using. Right now we will keep it as it is. We will see later on. But while using the Lamest theorem, it is either we are taking it as a inward or outward, that we will see later on. So mass of sphere is 100 kg. So can I directly write 981 Newton?
Yes, sir.
Yes, sir.
I hope now you understood, because I have already told you 1 kg is equal to how much? 9.81 Newton. So for 100 kg, it will be 981 Newton. So always remember this. Or W is equal to M into G. That is the formula that I have also told you. So these are the two forces I have drawn. Now my third thing is that this string. So this string will be, it is moved like this. This is the string. Okay. So here I can give the name. This is my point A. Up to this here, it is point C. And let us call this as point O. Okay. So what they have given us in the numerical, this AC. Okay. So this length is given to us up to this much. This length, it is how much? So they have given us this length as 100 mm. Okay. And also the diameter of the sphere is given to us. What is the diameter of sphere? Diameter of sphere is 200 mm. So if the diameter is 200 mm, then from this O to C, this will be the radius. बरोबर आहे ना? Diameter म्हणजे हे पूर्ण diameter असणार आहे. So O to C will be the radius. So this radius I can calculate. If I know the diameter, I can calculate the radius. So this will be also, if the diameter is 200 mm, so this will be also 100 mm. Okay, radius will be 100 mm. If D is 200, if my diameter is 200 mm, then my radius will be R is equal to, it is D by 2, so it will be 100 mm. And also you can see over here, this dimension, this is also radius from this point. This is also radius. If I show you, this is also radius. So this is also 100 mm. Now I can find out what is, why I am doing all these things, because first I need to find out what is this angle. I want angle. Whenever I want to solve the numerical by using Lamest theorem, first thing I should know all the angles. Here nothing is given about the angle. So to find out the angle, we should do something now to find out the angle. So now you can see, if I consider the triangle A, B, give this name as B here, ABO. If I consider the triangle ABO, this angle is already 90 degree. So this angle is theta. So we know the AO. AO is what? AC plus CO, that is 200 mm. BO is 100 mm. Okay. So from that, if we use the cos theta, then we will get the value of theta. So here I will use in triangle AOB. Okay. So in triangle AOB, I will draw this triangle separately again for your understanding. So if I draw over here the triangle, it is like this. Okay, so the triangle I will draw. This is the triangle. Here our point A is over here, point B is here, this angle is 90 degree, and here is our point O, and this angle is theta, which we need to calculate. This side is total 200 mm, and this total side is 100 mm. Just we want to calculate the theta. If I use cos of theta, then it is, what is the formula? Cos theta is equal to adjacent side. Okay, the cos theta is equal to adjacent side upon hypotenuse. So adjacent side is 100 divided by hypotenuse is 200. So which is equal to 0.5. So cos of theta is 0.5. So therefore theta is equal to cos inverse 0.5. Now if you solve this, you will get this theta as a 60 degree. Okay. this theta angle as 60 degree you will get. Now if I go back to the diagram, now I got this value of theta as 60 degree. If you see, I will extend this and I can draw it like this. Okay. Now if I draw the free body diagram of this, now whatever there already, if I draw the free body diagram, here also I will show so that there will not be any confusion to you. So I will show this is 981. Okay, so what I will do, I will erase this so that we will get the space and I can show it to you clearly. So here from the point O, there is a downward weight. This is 981 Newton, which is like this. Then here will be the reaction RB, which is horizontal. So this is the reaction RB. We don't know yet what is the value of RB. This is RB. And then the string is there. Cord means string. So here it is the always it carries the pull. So I will write here T, tensile force. Okay. So now I have calculated the angle. This angle is this one. Now I have got this angle is 60 degree. Okay. But I know that this angle is 90 degree. And if I extend it further, it will be like this. Okay. And the vertical line. I can know all the angles. Okay. So this angle, this remaining angle will be also 90 degree. This angle is also 90 degree. And this angle will be 30 degree. But now in this diagram, there is one problem. You can see this force is moving outward. Okay, that is away from point. Now you should think according to this point, because this is the point where all the forces are acting. Now you can see according to this point, if you see these are the three concurrent coplanar forces. This force is moving outward. This force is acting outward. But if you see RB, it is not outward, it is inward. So we have to apply the law of transmissibility of force to this RB, and we have to shift this RB over here. Okay, we need to shift this RB over here. Are you getting my point? So here you can see this angle is 90, this angle is also 90, this angle is also 90. Now if I shift this RB, see now this RB is there, I will shift this RB like this. Now you can see all the forces are become outward direction. Now we can use the Lamest theorem. Okay, all the forces will be in the outward direction. So these are the all angles. Okay, but while using the Lamest theorem, we require the angle between the two forces. Now I can show you what the exact angles are there. So here, this is my RB. So the angle between this is 90 degree, which is correct. RB and 981, the angle is 90 degree. Now the angle between T and RB, this total angle between T and RB, this total angle will be 90 plus 30, it is 120 degree. Okay, and the angle between this T and 981 Newton, this total angle will be 90 plus 60, 150 degree, and this will be 90. Okay, now see this free body diagram and let me know if any difficulty is there. Once you're done with this diagram, whatever I have drawn just right now, then your problem will be over. Just you need to apply the theorem. Is it understood whatever drawn over here?
Yes.
Yes, sir.
नक्की समजलंय का? काय अडचण असली आत्ताच
sir.
सांगा. महत्वाची डायग्राम आहे. हे मी कसं शिफ्ट केलं, काय केलं, तुम्हाला लिमिटेशन्स कळले. आरबी ला आपण का शिफ्ट केलंय सांगा मला. आरबी इकडनं येत होतं ना, आरबी ला आपण तिकडे का ढकललं?
Lamest theorem is applicable for outward forces.
फॉर आउटवर्ड और इनवर्ड बरं का, म्हणजे आयदर 3 फोर्सेस शुड बी आउटवर्ड और आयदर 3 फोर्सेस शुड बी इनवर्ड. ओके, एक तर 3च्या 3 फोर्सेस हे आउटवर्ड जाणारे असले पाहिजेत किंवा 3च्या 3 फोर्सेस हे इनवर्ड झालेले असले पाहिजेत. ओके, मग ते तुम्ही लॉ ऑफ ट्रान्समिसिबिलिटी ऑफ फोर्स वापरून करू शकताय की कसं करायचं ते. त्याच्यामुळे आपण आरबीला स्विच केलेलं आहे. सो नाउ दिस इज युअर फायनल फ्री बॉडी डायग्राम. Now you can use the Lamest theorem for this. And now if I write the terms by using the Lamest theorem, then what do I get here? So I will get T divided by sine 90 must be equal to R, that is RB, divided by sine of 150, which is equal to 981 divided by sine of 120. Now from this you will get the value of T and you will get the value of RB. Calculate these values, let me know the answer. Fast. What is the answer?
Five, six,
38 RB. Right? So I have written both the answers on the board. You can see. All of you are getting the same answer?
Yes, sir.
Okay. So now I hope you understood both the problems which we have taken today. So this is the problem of single sphere. Okay. So in the next lecture, we will take the problems which will be more complicated. So now your homework is whatever I have told you right now, right from the concept, the Lamest theorem and these two problems, that you need to revise once again, so that in the next lecture we will take the connected bodies problem. Okay, if the two spheres are resting on a surface, then how the reaction will be, how you can use the Lamest theorem, those problems we will take in the next lecture. Okay, so we will stop here over here for today.
सर आज युनिट टेस्ट असणार आहेत ना?
Today is which date?
25 जानेवारी.
For applied mechanics.
येस सर, युनिट टेस्ट आहे.
तुमची लास्ट पेपर कधी युनिट टेस्टचा?
29 जानेवारी.
January.
So we will take the test of applied mechanics on 30 January.
सर रविवार आहे.
हा, मग तुम्ही घरी असंही तुम्ही ऑनलाईनच सोडवता ना, घरी बसूनच सोडवणार आहे ना. तुम्हाला मी पेपर देतो ना ह्याच्यावरती, टेलिग्राम ग्रुप वरती. आय विल गिव्ह यू द क्वेश्चन पेपर. यू कॅन सॉल्व इट ॲट युअर होम. एनी प्रॉब्लेम?
नो सर.
सर MCQ ची PDF.
हा, ते करून पाठवतो. काय झालंय, मी नंतर आजारीच पडलो ना, त्याच्यामुळे आय वॉज नॉट देअर इन द कॉलेज. So when I will feel some better after some days, then when I will be in the college, I will send you the PDF. Here I am getting some network. कारण ते काय PDF आहे, त्याला ऑनलाईन तुम्हाला कट करून व्यवस्थित द्यावं लागणार आहे. So I am not getting that much of network to do that much of online work over here. So I will do it once I join the college. Okay, so 3-4 days may be required. So I will give it to you. But maybe at the max in the next week the PDF will be there with you. Okay.
सर आज टेस्ट घेत नाही का मग?
नाही, आज मी क्वेश्चन पेपर काय आज तुम्हाला देत नाही. तुम्ही तुमचं रविवारी सकाळी मी तुम्हाला ग्रुपवरती टाकतो पेपर, तुम्ही सॉल्व्ह करा तो पेपर, आणि तुम्हाला मी एक लिंक पाठवेन, त्या लिंक वरती अपलोड करून टाका तुमचे आन्सर्स. or otherwise Google form will be there, you have to solve it on that only. Okay. चला तुम्ही सॉल्व करून ते द्या. ठीक आहे मग.
ओके सर.
Yes, sir.
Okay. So now give me the attendance. Just 1 minute. Okay. So today is the date 25th Jan. Time 2 to 3. F 1B. Give the attendance. Roll number 1,
Present.
2,
Present, sir.
3, 4,
Present.
5,
Present, sir.
6,
Present, sir.
7,
Present, sir.
8,
Present, sir.
9,
Present, sir.
10,
Present, sir.
11,
Present, sir.
12. Roll number 12, 13,
Present, sir.
14,
Present, sir.
15,
Present, sir.
16, 17,
Present, sir.
18,
Present, sir.
16 is present. Okay, 18 is present. 19,
Present.
20,
Present, sir.
21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25, 26,
Present, sir.
27,
Present, sir.
28,
Present.
29, 30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36, 37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40,
Present, sir.
41,
Present, sir.
42, 43,
Present, sir.
44,
42 is present, sir.
42 is present. Okay, 44,
Present, sir.
45,
Present, sir.
46, 46 is present. Okay, 47, 48,
Present, sir.
49,
Present, sir.
50,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53,
Present, sir.
54,
Present, sir.
55,
Present, sir.
56, 56 is present. 57, roll number 57, 58,
Present, sir.
59, roll number 59,
Present, sir.
60,
Present.
61, roll number 61. Okay, so last roll number is 61, no?
Yes.
Okay. So today we will stop over here. We will see the next part in the next lecture. Okay.